So this is helpful question 9 of exercise 10b. First thing we need to do is realize what it's asking us to do. So we have got these two forces, F1 and F2, and they're given to us as such. There's A's in place of numbers for F2. A is a positive constant, and we've got to find the angle between F2 and I. So when it says I, it means the x direction, it means the x-axis, and F2 is pointing somewhere like this, so it's asking for this angle. That's what we're looking for. Okay, so how to do that? I'm taking a couple of steps back, and obviously this is a right angle triangle where you've got an angle, you've got opposite, adjacent, hypotenuse, you've got a right angle. All things like trigonometry will work on this triangle. And this is what we're given in the question. We've got the I component is A, the J component is 2A, and obviously the resultant F2 is going to be somewhere in the middle here, and we're looking for this angle. Now, what we need to understand is, if I moved this 2A line over, it would fit exactly here, and we would have a right angle triangle. And all right angle triangle things work, which means that we can do trigonometry. It doesn't seem like it's going to work because we've got A's in place, but if we do tan theta equals 2A over A, then the A's cancel and tan theta is 2, and if we work out what the inverse of 2 is, then we'll get what theta is. Okay, I won't finish that one off here, you can finish that one off yourself. And then the part B, so part B is, let's just have a look at the words again for part B. It says the resultant of F1 and F2 is R. Given that R is parallel to 13I plus 10J, find the value of A. So it's parallel. Because it's parallel, that means that this is going to be some multiple of this. Okay, it's pointing in the same direction. The ratios between your I components and your J components is going to be the same, which means the resultant for F1 and F2 is 3 plus A lots of I, and 2A minus A 2 lots of J. And I just put in mu there because I know that this is going to equal this because it's parallel. For some multiple, okay, it's not going to equal 13I plus 10J. It's going to just work for some multiple of it. So that means that the I components will be the same and the J components will be the same. And so this sets us up two simultaneous equations. And they look like pretty tricky simultaneous equations to solve, because if you think about expanding brackets and collecting stuff on one side and eliminating things, it's really quite difficult. But there's a little trick. If we divide them, then just like the A's cancelled out before, the mu's are going to cancel out this time. So the mu's are going to cancel out. And then what we've got then is 13 over 10 equals this. And again, this looks fairly tricky to solve. But if we cross multiply, then you've got this, which is a straightforward equation, which will get us the value of A. If you expand these brackets, collect like terms, it's a linear equation. You should be able to solve that. Okay, hopefully that helps, and hopefully you've done this sort of stuff in pure vectors already. If you need any further explanation, let me know. But otherwise, that's what I've got for you today.